Hi, it's Mr. Zachary. Here is a solution for number 31. Robin Hood is holding onto a rope. He cuts the rope and the chandelier starts to fall and he starts to accelerate upwards. This is very much like an Atwood machine from earlier in the set. His mass is 80 kilograms. The mass of the chandelier is 210. Part A wants to find the acceleration as he's pulled upward. Well, here's my picture of what's going on. Here's Robin Hood and the chandelier. If I find out the acceleration of Robin, I look at a force diagram for him, and there's the force of the rope on him, on Robin. There's the force of gravity on him. Over here, there's the force of the rope on the chandelier, and there's the force of gravity on the chandelier. Now, the nature of ropes is that they pull the same on each side. So really what we could do is we could treat all of this, him and the chandelier, kind of as one object, because when this goes down, he goes up. If it goes down 1 meter, he goes up 1 meter. If it goes down at 3 meters per second, he goes up at 3 meters per second. So they're kind of moving together, and so you can treat them all as one object. If that's the case, then the total mass would be 290 kilograms, and pulling one way, this way on that object would be the force of gravity on Robin, and pulling the other way would be the force of gravity on the chandelier. And those are the two forces that really are opposing each other in this situation. And they have to move 290 kilograms, or the total of them. So we find the force of gravity on Robin, it's 800 newtons. Find the weight of the chandelier, the force of gravity, and it's 2100 newtons. And so we know that the sum of the forces on them is 2100 minus 800. It's moving the total mass of 290 kilograms. And so their acceleration is 4.5 meters per second squared. B asks for the tension in the rope while he's escaping. Well, now we know the acceleration of Robin. And if we go back to this, we know that this one is 800, his weight is 800. We know his acceleration, we know his mass, so it isn't too complicated to find out the force of the rope. Here's our force diagram. We know that the force of the rope on Robin minus the force of gravity equals ma. We know that this is 800. We know that the acceleration of Robin is 4.5. And so the force of the rope on Robin has to be 1,160 newtons. It makes sense that it would be more than his weight because he is accelerating up as the chandelier falls. And then finally, how much time will it take him to get to the window 7 meters above? List down things that we know. Use one of our equations, plug in the numbers. He starts at rest, and so it takes him 1.76 seconds.